So we want to find the value of x and theta in this problem. We're going to round our answer to the nearest whole number if necessary. So what I want to point out on this particular problem is that we have a circle and that we are centered. This point here is at the center of the circle. Try one more time here with my pen. Here's the center of the circle. And this line right here is a radius of the circle. And when a radius intersects a chord of the circle, this being the chord of the circle, we form a right angle. So all of that information in this particular problem is given to you. But what we need to take a look at here is how are we going to find that length of x? And that's the most important thing for the test. And then theta is a little bit of review. But as we start, we go back to Pythagorean Theorem. We need to use the Pythagorean Theorem on this particular problem. Remember that Pythagorean Theorem is side squared plus side squared equals hypotenuse squared. So this is really going to be 8 squared plus x squared equals 12 squared. So we need to be able to recognize that the 12 is the hypotenuse in this problem. To solve this, we're going to subtract 8 squared from those sides. And when we do, we can flip over and into Desmos. And not yet, we can't. But flip over into Desmos. And we can type that in. So now, 12 squared minus 8 squared. 12 squared minus 8 squared gives us 80. And then ultimately what we're going to do to figure out what the value of x is we need to take the square root of that. So square root of 80 will give us our answer that we want to round to the nearest whole number. Since we see this here, and I'll show my work back on the smartboard in a minute, but we get 8.94. We want to round to the nearest whole number. Well, 8.9 is going to cause us to round to 9. So again, what we did, we subtracted, and we came up with 80. And then we took the square root of both sides. Came up with 8.9, but again, because it said to round to the nearest whole number, we're going to say that x equals 9. So what we're going to do now is we're going to take that value of 9, and we're looking specifically at this triangle. So I just drew this triangle out a little bit more because what we want to find is we want to figure out, well, what does theta equal? So here's our 8 that's already given. Here's the 12, and then here's 9, and then here's theta. This angle over here is what we're looking to find. So when we're looking to find this, we need to know the pieces of the triangle. So as we label, the one thing that we already knew is that this was the hypotenuse. If we go across from theta, this is going to be the opposite, which means that the side with the length of 8 is the adjacent. And now that we know that, we're going to use our trig functions to figure out the angle value. We want to find theta. Do you have a particular favorite? And it's not going to matter which function we use. Oftentimes what I've seen on a test or quiz is that people like to use tangent. I am a sine person. I usually use sine. But the tangent is going to be opposite divided by adjacent. But remember here, because I didn't teach it this way, I always wrote, in order to find the angle, we had to use the inverse. So that means when we get over here to decimals in a minute, we need to use this button. And then it'll come up like this. One other thing to remind you, when we're in decimals, we need to have the problem in degrees. And if you didn't choose tangent, if you chose sine or you use cosine, you should still get the same value that I get when I type in tangent. Flipping over here, go to the wrench and put it into degrees. So we can get rid of these. But as we pull up our functions, maybe pull up the functions, then we want to use this button. Again, 9 over 8. It's going to be 9 divided by 8, and we get 48.36. If we round to the nearest whole number, then we're going to end up with 48 degrees. So our angle equals 48 degrees.